Okay, let me go ahead and conduct the rest of the experiment and see if I got the same thing you got. And I can just report right off the bat that I saw no change on the cobalt chloride paper or the pH indicator when the T candle was not lit. So I have the lit T candle. I'm going to pop this on and we'll take a look. So we got two results to report on. One is the color of the universal indicator went from green to reddish orange. That's interesting. And also, you may have noticed, and this was slight, but the color of the blue cobalt chloride strip of paper went from blue to pinkish. So what can we make of these two results? Well, we know that when pH indicator, universal indicator, changes from green to an orange or red, that's an indication that the pH is going from a neutral pH to an acidic pH. And you can test this out yourself if you take a drop of vinegar or a drop of lemon juice or even like a drop of soda, Coca-Cola, and drop it into a drop of universal indicator, you will see that those three acidic liquids also change the color from a green to a reddish or orange. So result or conclusion number one is the gas of flame is acidic. That's interesting. Secondly, the gas of flame may be producing some water vapor. We of course know it's not just water vapor alone, because pure water vapor is not acidic. Pure water vapor has a neutral pH, and so it would keep the color of the pH indicator green. It wouldn't. So if it was only water vapor that's being produced, the pH indicator would not change from a green to a red or orange. But we know that water vapor is being produced. The one question, and this leads to some uncertainty of what's going on here, is maybe the wax is just, when the wax is melting, it's just giving up water. It's not necessarily the flame that is converting something to water vapor. But if it is, that would be a remarkable result to actually produce water vapor in a flame. And in any case, we clearly are showing that the gas of flame has at least one very unique property, and that is it is acidic. And that's very different from just regular air. Let me just make one more comment on the nature of what we're doing. And this comment's precipitated by the fact that we are studying something that was essentially ignored for most of science history. It was deemed an inert medium, as I mentioned. It's a colorless, it's odorless. Why would we study this thing that we now call air? But it marks a shift in human thinking. See, before the 1600s, when the theory of phlogiston was proposed, and scientists started studying gases in these methodical, systematic ways, most of science progress was made by intuition and logic, but without much experimentation. I mean, who would think, hey, let's put a piece of cobalt chloride paper next to a flame, or let's test the pH, the acidity of the gas coming from a candle. But this is the new way of thinking called empiricism that really took hold in the 1600s and 1700s, where scientists really almost set aside intuition, not completely, but set aside intuition and sort of elevated data and empirical data and data collection above what we think might be the case. And again, here's a great example. I mean, no way could you think yourself into this idea that, oh, the gas from a candle is acidic. So just an interesting comment to make. I'll see you in the next lab.